Which graph shows the magnitude of back EMF induced in a DC motor rotating continuously at different angular velocities? So before we go into the expression, what is back EMF? Back EMF is a type of EMF which is induced in a DC motor by virtue of its motion inside the magnetic field. So coming to the expression, we can write it as E, or you can call it as back EMF, or maybe we represent simply with the letter E. And if you remember the formula, that will be given by minus N d phi by dt. So over here, if we expand it further, it will become minus N d by dt of B dot A, which will be BA cos theta. And what is theta? Theta is the angle which the normal to the area A makes with B. So this in turn can be written as EMF is equal to minus N d by dt of B A cos omega t. Yeah. So where omega is the angular velocity or angular frequency. Yeah. And if we differentiate this part, so we see that B and A are constant, so they can be taken out. So that will be equal to minus N B A, and what is differential of cos theta? It is minus sine theta, so that I will make it as plus, and that will be sine omega t, and differential of omega t will be omega. So if I can rearrange it and write it as, so that will be omega N B A sine omega t. And this in turn can be written as, maybe I'll write it as E max into sine omega t. So E as a function of time will be following a sine curve. But let's see what is being asked in the question. It says magnitude of back EMF. Yeah. So we see here that E, which is magnitude of the back EMF, will be proportional to E max, and which in turn is proportional to omega, directly proportional. Yeah, if omega increases, then E also increases. And we also see that E is proportional to sine of omega t. So both the conditions are there. So E depends on both omega as well as sine omega t. But in the question, he is asking only the dependency between E and the angular velocity. So angular velocity is same as omega. So we have to make use of this expression. So there is only one graph which matches the condition that as the angular velocity increases, the magnitude of the back EMF also increases directly proportional to it linearly. And if omega is 0, for example over here, then EMF is also 0. Yeah. The question here, it is important to note that the question does not take into consideration this factor. Yeah. So since question remains focused on only the dependency between E and omega, so option D is correct.